Hello, it's Mrs. Leggett here. You may remember me from such hit videos such as pesticides or fun with fractions. I have many awesome videos. Okay, today we're going to do something, a little experiment kind of, that has to do with plate tectonics. So hopefully you've already watched the Brain Pop video about plate tectonics. Plate tectonics just means the globe is covered in lots of large plates of, well, rock. It's the crust of the earth. It's not just in one huge piece, it's split up, and those different plates or pieces are all sort of floating over the mantle of the earth, the middle of the earth where all the magma is. So in some spots, these plates are hitting each other. In other spots, the plates are slowly moving apart. And in other places, huge fault lines have formed and the pieces of the plates are moving sideways like this. So we're going to talk about what those cause and sort of what it looks like. So let me show you what I have here. Basically, I've got expired sour cream. That was from my fridge. Red food coloring to make it look like this is my magma. Now, in Mosa Mac, it says you can use Cool Whip. It doesn't really matter. And if you wanted to recreate this at home to try it yourself, you may. What you would need is something like Cool Whip, sour cream, yogurt, red food dye, and then you need graham crackers and water. So I have 4 different plates here, and I'm going to show you what the plates do at different parts of the earth and what it forms. So the first one is just going to be what's called a divergent plate boundary. Now tomorrow we're going to do a picture of all of these in our science notebooks so that we can remember them for when we take the test. So these are 2 plates. See, we're pretending they're the huge plates on the crust of the earth. So I'm going to put them here in my magma. You can kind of see it a little bit. So here they are on top of the magma. And just like I said, the pieces are floating over the magma that's in the mantle of the earth. Now, divergent means that they are going apart like this. This is what's happening in the Atlantic Ocean that has caused Africa and Europe to float away from North America. And so it kind of just slowly over time scooches and scooches and scooches. Now basically what that does is obviously it's opening up a huge rift in the ocean floor, which is exposing weak areas and also allows for magma to come up through these rifts in the ocean floor. What does that create? Well, it either creates magma coming up and forming new land. That was how the Hawaiian Islands were formed, and also mountain ranges underwater. So in the middle of the Atlantic Ocean is a huge mountain range. We can't see it because it's under the ocean. But that was caused because those 2 plates are divergent, shifting away from each other. Okay, so I'm going to move on to the next one. Now in this one, we're going to talk about the San Andreas Fault in California. So right there's a huge crack that was formed right by the plate boundaries of the North American plate and the Pacific plate. The Pacific Ocean is one huge plate. In that spot, right by the San Andreas Fault, the 2 pieces, here they are on the magma, they aren't hitting each other this way, going toward each other, and they're not moving apart like the divergent. Instead, this is called transform boundary, and they're going like this, back and forth. Now what that causes is sometimes it gets stuck, and then all of a sudden, it starts moving and it lurches forward. Okay, when it does that, that is when you have a big earthquake in California, when the plates have lurched against each other. And as we saw in the Mosa Mac video, that's like dropping a pebble into some water, and then it just concentrically, in little ripple circles, goes out. And the further out you get, the weaker the earthquake is. But right there where it's the plates of Lurch together, that's where it's the strongest. That's called the epicenter. And scientists measure that with something called a seismograph. That basically measures that movement in the earth and how strong it is. Okay, so we've got two boundaries down. We've got transform, and divergent is when they're pulling apart. So we're gonna move to the next one. Man, that expired sour cream smells so good, right? Okay, now for these ones, I'm going to get some graham crackers wet. So I'm going to kind of dip the edges of these two in water. Now let me explain why I'm doing that. Because sometimes there's some, the crust plates, the tectonic plates are not all the same width or the same density, right? Some of them are thinner in other places and thicker in other places. So when that happens, when they meet up, sometimes one of them goes under the other one. In this case, and look, I've just completely pushed that like it's so wet it's going into it. So we've got two pieces. These pieces are the same density. And so when you put them on the magma like this, and we're gonna converge them, so divergent was going apart, convergent is going together. And the way you can remember that is convergent has a C for crash. They're crashing. So these two are crashing. They are the same density. So what happens is they crash, and notice where I made the graham cracker wet, basically they're pushing together and they're pushing up the edges of the graham cracker. So that's supposed to represent when mountain ranges are formed. So basically they converge or they crash, and then they go and they ripple and they push against each other until you have a huge mountain range. And obviously we live in Utah. We have a huge mountain range, a couple of them that go through Utah. This was how it was formed, and there's a word for that. It's called uplift. So just places where the plates are moving and shifting against each other and buckling. So we have one more to talk about. So again, convergent, remember, that means crashing, they're going together. Divergent means they're going apart, and transform, they're moving like this. There's one more convergent one we're gonna talk about, and this is how volcanoes are created. So here's my last bit of sour cream magma. Oh, I need a couple more of my graham crackers. Okay, so for this one, you know how sometimes I said pieces of the crust, some of them are thicker than others. So in this case, the Pacific plate, that's most of the Pacific Ocean, is a little bit denser than the North American plate. So in this example, I'm going to make my Pacific plate wet because I'm going to make it a little bit thicker and denser. So what happens is I'm going to end up putting them on the magma, and what ends up happening is the wet part, when I squish them together, the part that's denser is actually going to start going under. This is hard to see. One of the pieces starts going under the other. And the word for that, I already said convergent because that means crash. But when one starts going under the other, that word is called subduction. And convergent subduction means that this piece goes down there where there's intense heat and magma and pressure, and some of this rock down here starts to melt and become part of the magma and increases the pressure and pushes up. And that is what creates volcano, until there's so much pressure that eventually when the magma reaches the surface and there's nowhere else to go, that's when volcanoes like Mount St. Helens or Mount Rainier blows their top, because the pressure can't stay in, right? It's got to get out somehow. So that is plate tectonics. And again, tomorrow for Tuesday in science, we are going to draw in our science notebook these different boundaries, and so we have them so that when you review later for RISE testing, you will know. If you have any questions, you can email me and I will be in touch. Okay, bye.